So we want all children to develop as mathematical problem solvers. A barrier, well, what if we say they don't have the fluency to solve the problems? They've got to have that first. So in developing problem solving sequences, one thing I would think, how can we remove those barriers? And one aspect of that will be thinking, what's the domain specific knowledge that children need to have success with grappling with this problem solving task? Now, we know the importance of activating the schemas from long-term memory to lessen the burden on working memory and to consider the relevant schemas for the problem today. Expertise in various domains depends on having access to some 50,000 chunks of knowledge in long-term memory. So if we can access and activate the relevant prior learning from long-term memory, that will lessen the demand on working memory. So I might look back at a task and think, I need to develop this content knowledge for this task. So I must activate it before children engage in the task. That might be for some, it might be for all. So let's say there's a task I'm building up to. My numbers are 7 and 4. The sum of my numbers is 11, because 7 plus 4 equals 11. The product of my numbers is 28, because 7 multiplied by 4 equals 28. And I'm helping the children to become fluent with the terms sum and product. And I might say to them, right, your numbers are 6 and 3. What's the sum of your numbers? What's the product of your numbers? And here I'm activating the necessary prior learning that will build into this problem-solving task here. And it could even be that I introduce it in stages. So I think of 2 numbers, and I give children the sum of my numbers is 12, and then hide that clue. What could my numbers be? And then we see the product of my numbers is less than 30. And now I can access the task in a way I may have been unable to before, because I've just activated the relevant prior learning before we engage in the task. So here's another problem-solving task, lots of different layers. And again, there's domain-specific knowledge I might need to check that children understand before they actually engage in this task. So a build-up might include, so my numbers are 4, 10, and 7. What's the sum of my numbers? What's the difference between the largest and the smallest number? I could show the children, well, the sum of those 3 numbers is 21, and the difference between the largest and the smallest number is 6. And say to the children, right, it's your turn. What's the sum of these numbers? What's the difference between the largest and the smallest number? This might be just for some children, if necessary, so that they're going to engage in that problem-solving task later and breaking down the barriers. A further practice that isn't doing that problem-solving task for them, but is making it more accessible. Have a look, there's 4 numbers, I've hidden 2 of them. The sum of the 4 numbers is 20. The difference between the largest and the smallest number is 4. What could the 2 hidden numbers be? I could explore that one. Or the sum of the 2 numbers that are hidden there is 9, and the difference between the largest and the smallest of those 2 numbers is 5. And we could think, well, what could those numbers be? And then that means when I come to this task, I can end up having greater success because I've thought about the necessary knowledge that needs to be broken down. So it might be that children, you don't feel initially have the fluency to solve the problems. But if we can work backwards from the task, then maybe we can help all children to access those different problem-solving tasks.